G'day viewers, this month we're following up on last month's planning to migrate from Access to SQL Server backend database. This month we're going to have a bit more of a deep dive into mapping the data types because the data types in Access have little bits of differences with that in SQL. So to start off, Crystal's going to take us through the data types. So take it away, Crystal.
Hello everybody, it's really good to be here with you. And I'm really looking forward to this meeting. Thank you, Kent. I'm Crystal, and I'm going to show you a summary of the basic data types in Access. And there's a few others on this list as well. And which ones are the most commonly used, which ones are the best to use, which are problematic, and then we'll touch on some other types that aren't as common to use. So at the top of the list is yes, no. When you pick a data type as yes, no, the default display is a checkbox. Now, the thing that's different about yes or no is it's only got two values. There's no such thing as null or a value not being filled out yet. It's going to be true or false. Now, in Access, true is -1 and false is 0. In SQL Server, true is 1, but false is still 0. So basically, false is 0, and anything that's not a 0 could be true. Now, on the link that Microsoft has for the data types, they say the yes-no field takes 2 bytes to store. I actually changed it on this chart to 1 byte. Because I've heard that yes, no is just a crippled integer because integer actually can have a null in a table, whereas yes, no can't. But then I've also heard that it could be just a string of bits, and that's why it can't have a nothing value. A lot of times, if you're going to use a yes, no field, there might be a better alternative. Like if you have did they receive the invoice? Instead of a checkbox for that, what you might want to store instead is a date received invoice so that the field also has some meaning. Now, I know I've kind of spent a lot of time on this yes, no, and the reason why is because it's at the top of the list and it's also in gray. I colored things in gray when you might want to consider using them or not. Sometimes, yes, you just want a checkbox. It's an easy thing to do. So there you have it. The next data type on this list is byte, which can be from 0 to 255. It's an unsigned whole number. That means it doesn't have any negative values. That's also not a really good data type to use unless you have a specific reason to do so. Now, the next data type is also a number, integer, which can be plus or minus 32,000, 32K more precisely. And it's a whole number. It is signed, and it takes 2 bytes to store. Now, long integer, I put in bold and also made it bigger, because long integer is a pretty common number to use when you want to store whole numbers. They can be a lot bigger than integers, and an integer is going to take at least the space of a long integer to store anyway. So unless you're wanting to limit numbers to less than plus or minus 32,767 or 8, you might as well use a long. Currency is number on the left, the type. That's the actual type number that Access is storing when it makes a field with this type. So currency is usually used for money. Not necessarily so, but it can have like up to 15 places before the decimal point, and it has precisely 4 places after the decimal point. Now, I believe also when you have a currency data type, Access does rounding with bankers rounding, if I'm not incorrect about that, which is a little different than scientific rounding, because scientific rounding, 0.5 and up is always rounded up. But with banker's rounding, it depends on whether it's an odd or even number, whether it goes up or down. But it's also just really good so that your fractions of a penny actually add up to a penny. Next, we have floating point numbers, which are actually stored in scientific notation, single and double. The difference between the two of those, so a single precision number takes 4 bytes to store. Over there, I'm looking on the right under the byte column. The double precision number takes 8 bytes to store. And what's different is how many significant figures there are. These numbers are not precise. So if you're going to compare them, you need to use some kind of a tolerance, because even though they might actually be equal when they're stored in scientific notation, there might be some difference out at like the 10th decimal point. So they're not good for exact comparisons. What they are good for is storing extremely small or extremely large numbers. Now we have date and time, which is kind of a problematic data type. Well, it is a problematic data type. However, we all need to use it. The thing is, date and time actually internally is stored as a number. So the lowest date is the 1st of January of the year 100, and that's like a really low negative number, as you can see on the summary, minus like 657,434. And the highest date is a high number. However, even though internally date and time is stored as a number, it's displayed depending on where you are in the world and what your Windows settings are. So the whole part of the number is the date, and then the fractional part of the number would be the time. So halfway through a day would be 0.5, would be the decimal place. Or if it's 6 o'clock p.m. or 1800, then it would be 0.75, would be the number after the whole number. Date times take 8 bytes to store. Short text is up to 255 characters. Now, there are people that say, oh, it doesn't matter. Just leave it at 255 all the time. I disagree with that. If you have shorter values that you're possibly going to index on, like a code or a phone number or something like that, it's good to set the size not longer than you would expect the data to be, because when you make an index, although the field value is dynamic, when you make indexes, they actually take all the space that you have allocated. So if you said something that won't ever be longer than 20 is 255, you're going to have a huge index. So just keep that in mind when you set your length for short text. Long text is actually not stored with the table. That allocates space in blocks. And just like if you're grabbing a piece of paper and you're going to write something, even if all you write is one thing, you've used that whole piece of paper. So you've used that whole block. Now, if you want to write some more, you go get another piece of paper. So that's the way long text works. It has blocks of space. You can have lots and lots of characters in long text, and it can also store formatting if you set it to store rich text. That takes, there's no bytes on there because it just really depends on how much you have. Decimal is up to 29 significant figures. It is the most accurate as far as the number with decimal places goes. But the problem with decimal in Access is in VBA, there's no specific decimal data type. So although it's a really good way to store information, it's problematic to manipulate it with VBA. DateTime2 and BigInteger, not really going to talk about those two very much. They're on this list because they've been added to Access so that there is some compatibility with SQL Server, but you have to go into your options for the current database to enable them. And then once you do that, your database can't be shared with people with old versions of Access. GUID is also on this list because most people, when they make a table in Access, they make a primary key that's an auto number. And by default, it's a long integer, which takes 4 bytes to store. Now, you can also alternatively say your auto number is a GUID, in which case it takes 16 bytes to store, or you can also just set up a field as a GUID. And then last on this list is just a calculated field where you can put an expression in. And if you use calculated fields, you won't be able to share backwards. I think calculated fields didn't get introduced to Access 2010. So if you want to be able to open this in 2007, then don't use calculated fields. I find them kind of nice, but I don't sort on them. I mean, if you're going to pull a calculated field into a SQL statement or a query, just remember, sort on something other than the calculated field. Sort by what it's actually calculated on. So that is a really quick tour through the data types you can set up in Access. And now Kent will show us data types for SQL Server. Take it away, Kent.
Thank you, Crystal, for that insightful overview of data types. I'm now going to have a look at data types in SQL Server and how I use my limited palette of data types, starting with bit. Yes, no, but in SQL Server, unlike Access, you can't have a null in a bit column. A bit column is just that, a 1 or a 0. So you need to give it a default value in case somebody adds a record and forgets to tell you what their value is, in which case you would throw an error if you don't have a default. So make sure you've got a default. One of the nice things about SQL Server is that it allows you to set value of a new column in existing records when you actually add that new column. So that's quite nice. Now, if you do need to use nulls, then we might have to go to something like a small integer or a tiny integer. Small integer is the equivalent of Access's integer. It does allow null, and it's signed, so it can go from minus 32,768 up to 32,000. Now, if you're using it as a yes/no, you obviously won't need to do that. Okay, so TinyInt is even smaller than a SmallInt. It doesn't allow you to go into negative territory, so it's only 0 to 255. But if you want to use it as a yes/no, you can have a null value if you so desire. Int is the data type I use for primary keys and foreign keys, and also for things like whole numbers, where I may want to use it for the number of records or something like that, which may exceed that 32,700 odd record limit for small ints. So I just tend to go to integer. Speaking of defaults, you can use a default value, something like customer ID for the cash customer in your invoice table as a default. And this is quite nice when you come to wanting to delete all of your old customers that haven't done business with you in ages. You can actually use a cascade option to cascade to default, so that if you do delete those old customers, that will update all of those invoices to use cash customer instead of the old customers, and you don't destroy all your invoice records in the process. So that's quite nice. BigInt, if your int isn't going to be big enough, and as you can see there, it goes to a very big 8-byte number. which is the same data type, in fact, as what RowVersion uses. RowVersion, despite the old name called timestamp, has no date or time element to whatever. It's just a big, wide, incrementing auto number. It's 8 bits, so it's really big, hence it's usually displayed as hexadecimal. Every table should have one. You don't really need to do much with it, but SQL Server will use this to determine whether two users are trying to change the same record at the same time. So make sure every table has one. Decimal is what I use for numbers that are not whole numbers. SQL Server does have a float data type, but I tend not to use it. It doesn't work quite the same as the Access one, and I like to have a little more control over my precision and scale. Precision being how many numbers, how many digits there are rather, and scale being how many of those digits are to the right of the decimal place. So typically I'll use 18.4, 18.2, or in some instances where I want to use a percentage that only goes up to 100, then I might use a scale of 2 but a precision of only about 3. Money is pretty much the same as currency in Access. In fact, it's almost exactly the same as currency in Access. It goes to 4 decimal places, and usually I give it a default of 0. VarChar is a little bit more complex than it is in Access. You've got a few more options. We've got a VarChar data type if you're only having to store non-Unicode characters. If you want Unicode, because you've got accents and what have you for foreign languages, you need to use the NVarChar data type. The NVarChar data type is going to use twice as much space to store it. Not that that's a big deal, but you just need to keep these things in consideration, because particularly when you're doing indexing, if you want to go to unlimited like a memo field, then you can use a VarChar max or NVarChar max and go up to 2 gigabytes, but you can't index on it. And obviously index is going to be faster the smaller the field is. Speaking of which, if you want a really small text field for something like a state code or a country code, then you can go to Char. So you might want to have a country code that's 3 characters and just store like USA, A, US, NZ for New Zealand, bearing in mind that if you only put in 2 characters, 3 characters will actually be stored. 2 characters and then a blank space for NZ. So that's my overview of data types in SQL Server. We can go into more detail later if we want to. So next month, we're going to have Greg Reagan back, and he's going to be showing us more about his modern take on user interfaces for Access. So, hope to see you then.